everyone, this is Professor McCormick back again with a video. This time we're going to talk about the quotient rule and maybe another approach to seeing how that works. And this video follows a video that was on the product rule, and it's going to precede a video on the chain rule. So if you'd like to watch those videos, it might be helpful to watch the product rule first. Again, we're looking at our function, and let's say this time we're seeing two smaller functions inside of our large function, let's say f of x or some such thing, and they're being divided, and there may or may not be parentheses around them. So again, just like with the product rule, it might be helpful to rewrite this just so that you can easily see them. They do tend to be a little easier to see just because they're separated by the line that tells us we have a quotient there. But imagine we have f of x, and let's say it's equal to x squared this time over a 5x minus 2. Remember, I could rewrite that if I wanted to as an x squared. That's one of my little functions, and it's divided by a second little function, 5x minus 2. Let's say I have a g of x function. If you don't feel the need to rewrite these, don't worry about it. Here I'm going to have a natural log of x divided by a 2x squared. And I can rewrite that again with the parentheses. Natural log of x over a 2x squared. And I put parentheses around that. Let's say I have that, the one that we had in the last video, h of x is equal to, let's say that sine x over x to the x to the 3, sorry. Then I can write this one and use the quotient rule with it instead if I don't want to do what I did in the product rule one. And I have a sine x on the top and an x cubed here on the bottom. One more, we'll do a y one this time. I have a y equals 5x squared e to the negative x, which leads me to have to do some slightly different math. So I can say that's equal to 5x squared all over e to the x, because remember this negative exponent right here just means that this is actually in the denominator down there. All right. And if you're hearing the plane, I apologize. I can't avoid the planes flying over. So sometimes it's easier to see these if you put the parentheses around them. It's easier just to identify, and I left them off, that e to the x down there because I'm so excited it moved to the denominator. Okay, so we have them written, and we can see that there's two smaller functions that are being divided or that form a quotient, all right? So here, since I'm looking at these two functions that are being divided, I'm going to go ahead and use the quotient rule for these. And you remember the quotient rule, we use them when I have these two smaller functions that are being divided. One is divided by the other. So if I say have a function u and v that are both functions of x for this particular example, and they're smaller functions, they're being divided, and we have to make sure v, our denominator, is not equal to 0. Then I know that the derivative of u divided by v, or that quotient of u over v, is equal to v times the derivative of u. So that's the first one, minus, and here's, order is very important, u times the derivative of v, all divided by v squared. We could write it as vu prime minus uv prime, all over v squared. Or you can use the little memory thing, low d high minus high d low over low squared. So let's say we use that one, and we'll use it just on the very first one here. So I'm going to do one example this way, and I'm going to show you another example, just so you can see that they work out the same. So let's use our f of x that was equal to an x squared over the 5x minus 2. And so in this particular case, my v is the 5x minus 2 because it's in the denominator, okay? So this will only hold true when 5x minus 2 is not equal to 0. So I can't have an x equal to 2/5. All right, otherwise this doesn't work at all for me. It's not a part of my original function anyway. So let's take the derivative. We're going to take the derivative of this. I tend to like low d high minus high d low just because it's easy to remember. So I'm going to take my lower function, that's my 5x minus 2. I'm going to multiply it by the derivative of my upper function, my high function, which is 2x. I'm going to subtract, and I'm going to say minus high, that's my 2 or my x squared there. D low, the derivative of my lower function is just 5. All divided by low squared. I always say this is the easy part because all you have to do is write the same thing and square it. So if I want to multiply this through, I can say that means this is 10x squared minus 4x minus 5x squared. Be sure that when you're looking at anything out here that you distribute that negative sign all the way through any quantities you might have there. All of this over 5x minus 2 all squared. So if I combine my like terms up there, I'm going to end up with a 5x squared minus a 4x all over 5x minus 2 squared. Right, so that's my answer there, and that's traditionally how we've done this in class. However, if we want to look at something just a little bit different in the way of doing it, we can go back to making the x or the tables, the crosses, kind of like what I made with the product rule, and we're going to use that for the quotient rule. So another approach for the quotient rule is to use the table. Let's define the two smaller functions, u and v. They're functions of x. Make sure that v is in your denominator. That is critical. That's why it's highlighted there. If I could bold it, I would. So I have u over v, or the quotient u over v, or u divided by v. All depends on how you want to say it. Then we make the same table. So we have our u equals this and our v equals this. We can take the derivative of u and the derivative of v. We're doing exactly the same thing that I did before. This time, to find my derivative of u over v, or of that quotient uv over v, we multiply across the table again, and we say v u prime. That's right here. This time I'm subtracting. This is largely because I have this line right here. So I'm subtracting, and I'm going to say v u, or uv prime, right here, all divided by, I have one more step, v squared. Okay? So let's see how this works with our previous f of x function, and I'll do a couple of extra examples too. So remember we had f of x was equal to my x squared over the 5x minus 2. So here I'm going to say, remember my upper function, and maybe that's why I called it a u, I don't know, or maybe I was just lucky, is equal to x squared. My v is equal to a 5x minus 2. You can see those from the function right above you. Then u prime, my derivative of u, is equal to 2x. My v prime is equal to 5. All right. Now we're going to say that my derivative of f is going to be equal to, and I'll change pen colors again for you so you can see it. I'm going to go this way across. This is important. You have to go that way across to start. I'm going to have 5x minus 2 times 2x. And now as I go up, remember, because I'm dividing these two, I have to subtract. So I'm going to subtract there. I'm coming up this direction. I'm going to go across here. And I'm going to have x squared times a 5. And then I'm going to divide all of this by, divided by my v squared. So I'm going to divide by my 5x minus 2 squared. You'll find this time that we have a 10x squared minus a 4x minus a 5x squared, just like we had last time, all over 5x minus 2 squared. Again, we can combine our like terms so that we have a 5x squared minus a 4x all over my 5x squared, no square, 5x minus 2 squared. So let me get rid of that little dot there. All right. So that is my derivative, f prime. There we're using the quotient rule. Let's give it a try for my second example that I had there. I had a g of x, which was equal to the natural log of x. This is my upper function, so it's a u, divided by 2x squared. So I'm going to create my little table. And I'm going to say u equals natural log of x, and v equals 2x squared. Not too bad. I'm going to take the derivative of my upper function. The derivative of natural log, you'll remember, is 1 over x. And the derivative of my v, my denominator, is going to be equal to 4x. So now, let's go ahead and say that my derivative of g is going to be equal to, I'm going to go this way across, so I'm going to say I have a 2x squared times a 1 over x. Remember, I'm dividing, so I need to subtract here, minus, and I'm going to come down this direction, I'll make an arrow to get up there, minus my natural log of x times 4x, all divided by my v squared, which is just going to be my 2x squared. I want to square that whole quantity, okay? So I'm squaring the 2 also. Don't lose that. It does cause problems. So here I'm going to have a 2x squared over an x on that first term minus 4x natural log of x all over what, if I multiply and actually square this, is a 4x to the 4th power. So let's simplify this term right here because I have an x in both numerator and denominator, so I can get rid of my fractions and fractions. I'm going to have a 2x minus a 4x natural log of x, all divided by a 4x to the 4th power. One of the things I notice here is that right here and right here, I have a common factor of 2x that I could factor out. So let's see if we can clean this up even more. I'm going to say 2x times 1 minus 2 natural log of x. I've just factored out a 2x from each term, all over 4x to the 4th. Now you notice that in my numerator I have a 2 and in the denominator I have a 4, so I'm going to be able to cancel those out like so. I'm going to have a 2 in the denominator left, and I also have an x in the numerator and an x to the 4th in the denominator, so I'm going to cancel this one out with this one and say it's an x to the 3rd. I'll rewrite this in its final form, which is, well, I can drop the parentheses, 1 minus 2 natural log of x all over 2x cubed. And that's our final derivative for this one. A little bit easier to see what's going on here when we do our crisscross and then our division. All right, let's take a look at another one. What else did we have? We had an h of x, which was equal to a sine x over an x cubed. And those were both in parentheses. If I make my crisscross, I'm going to have my u, my upper, is equal to sine x. I have my v, which is my lower, equal to x cubed. My derivative of sine x, my u prime, is equal to cosine x. My derivative of v is equal to 3x squared. All right, so let's find this. We're going to find our derivative of h. We're going to cross over this direction, and we're going to have an x cubed times a cosine x. Remember, I'm dividing, so I'm going to subtract right here. So I'm going to pop up to the top, and I'm going to come across this direction, minus the sine x times a 3x squared. And this is all divided by, remember, my v squared, so I'm going to say divided by x cubed squared. Let me switch back to a color other than red. It's just not my favorite to write in. So here I have an x cubed cosine x minus a 3x squared sine x. I'm just moving that out front so that my trig functions are at the very end, over a x to the 6th, because x cubed times x cubed is equal to x to the 6th. Now, again am going to notice that I have an x cubed here. Actually, I have an x cubed here and an x squared here. So I can factor out an x squared from both terms. So let's go ahead and do that. So we're going to say this is equal to an x squared times an x cosine x minus a 3 sine x, as I run out of room over here on the edge. I thought it would fit, over an x to the 6th. So if I take away 2 of the x's here and 2 of them here, I'm going to be left with an x to the 4th. My final answer here is going to be x cosine x minus 3 sine x over x to the 4th. All right, let's add one more page here. So I'm going to add one more page, and I'm going to get rid of this side part. Let's do that very last y function that I had there. We had come up with a y is equal to a 5x squared over an e to the x. Remember, this is the one where we put that negative exponent and we put it back down in the denominator. So we're going to put our little cross and we're going to say u, my upper function, is equal to 5x squared. My lower function, v, is equal to e to the x. My derivative of the upper function is equal to 10x. And the derivative of the lower function is e to the x. You've got to love the e's. Alrighty, so now if we find our derivative of y, or dy dx, depending on how you want to write this, we're going to go ahead and go across this way, just like we've been doing, and we're going to have an e to the x times a 10x. Because I'm dividing again, I'm going to subtract these terms, so minus, I'm going to go across this way, my 5x squared times e to the x. All right, all divided by my v squared. So I'm going to put my e to the x squared, and I'm going to leave that like that for right now. What I'm noticing as I look at this is I have an e to the x right here and an e to the x right here. So I'm going to factor them out. So I'm going to have an e to the x times 10x minus a 5x squared all over an e to the x squared. I can get rid of one of the e to the x's in the denominator because I have one up here and I'm going to make that one go away. So I just have a 1 down here. And rewrite this and clean it up and say that it's equal to 10x minus 5x squared over e to the x. And that's my final answer. I hope you found this helpful. If you have questions about how to use the little cross table or anything else, please let me know. Happy to help. And stay tuned. The next video will be on the chain rule. Have a great day. Bye.